All right, welcome to another edition of Comet Algebra. This video is entitled Review of Algebra 1, and it's intended to be used with this last section of your summer packet. So congratulations at making it this far through the summer packet. You are almost there. So I'm going to skip around a little bit in this video, but we're going to cover all the topics you need to finish this last part. Problems 1 through 6 look fine. I think you got that. But we do need to talk about problems like 7 and 8, equations with radical signs in. So I wrote down up here some basic steps to refresh your memory. You do need to first isolate the radical sign, get it all by itself on one side of the equation. And then to get rid of the radical sign, you need to square both sides and then solve whatever equation you're left with. So let's look at an example of this. In this radical equation, first I do need to isolate the square root by adding an 8 to both sides. So if we add an 8, we get 11 is the square root of x minus 1. Now it's isolated. We are ready to square both sides. So we get 121 equals x minus 1. Because this square root symbol and the squaring undo each other, add a 1 to both sides, and we get x is 122. And we do want to check this because it is possible to get garbage answers. Under here we'd get 121, so this is 11. 11 take away 8 is 3, so this works. But if you'll notice, on your problem number 7, in this location, you do not have a number, you have an x. And so when you square both sides in number 7, you are going to get an x squared, which gives you a quadratic equation. So what I want to do is take a minute now and review how to solve quadratic equations, because that's what you're going to end up with both problems 7 and 8. So we have several things to do with this quadratic equation. First, we need to set it equal to 0. We need to get all our terms on the same side of the equal sign. So we're going to add a 2x to both sides and subtract the 63 from both sides. And now we have our quadratic equation in standard form equal to 0. And in A1, you learned different methods. You learned the factoring method, using the quadratic formula method. I like to do factoring if it works out. So remember the diamond box or the lollipop. What I want to find, I want to get the number 2 using factors of 63. And so one thing we did, we made a list of all the factors of 63 and tried to see which ones of these, when they multiply, we get 63, and when we add them, we get a 2. So when I look at this list over here of factors of 63, I notice that these two, 7 and 9, are 2 units apart. The 2 needs to be positive and the 63 negative, so these signs have to be different. And in order for the 2 to be positive, this 7 would have to be negative. So we factored this into x minus 7 and x plus 9. So you just got a quick review of factoring here. So now let's finish solving this. If this factor times this factor equals 0, we asked ourselves, well, what makes this 0? X minus 7, if that's equal to 0, x would be 7. Here, what makes x plus 9 equal to 0? Well, x would equal a negative 9. So in problem 7, after you square both sides, use this method to solve it, and it is a quadratic, so you will get 2 answers. And the same thing is true for number 8, except with number 8, we need to review one more skill that you will have to remember. And the skill I'm referring to, we called foiling. I'll just make up an example here. In your problem, number 8, when you isolate that radical, you are going to be adding an x to both sides. And you'll get something that looks like this, and then you're going to need to square both sides. So I thought I'd review this all in one step. So this is a binomial, and you're squaring it. And if anybody tells me that this is equal to x squared minus 25, I will get very angry, yell at you. I'm trying not to, get violent or anything, but I've been known to throw erasers at people or smack them with rolled up paper. But you have to remember, when you are multiplying a binomial, this involves 4 different multiplications, and we use the acronym FOIL to help us remember that. It may also help you see it if you write it as the binomial times itself, and then you draw these arrows to help you remember all 4 of the multiplying that you have to do to get this correct. So x times x is x squared minus 5x, the outer product. The inner product is another minus 5x, and the last times the last is 25. So usually when you FOIL a binomial, you do get a trinomial. And in this case, add the 2 middle terms together, and you get x squared minus 10x plus 25. So you're going to have to use this skill on number 8. And again, get all the terms on one side, get your quadratic, and then if you factor it, you will get your 2 answers. All right, now for looking at problems 9 through 14, we need to have a quick review of exponents. I cannot emphasize enough how important it is for you to review exponents and know them. Much of what we do in Algebra 2 is built on these properties of exponents. Logarithms themselves come directly from these, so totally worth your time to review this. Very, very important. When you multiply like bases, that's like if you had 3a to the 4th and you were multiplying that by 2a squared b squared. The like bases that we have in this problem are the a's. The numbers, you multiply them just as you always have. So 3 times 2 is 6. A to the 4th times a squared. When you multiply like bases, the shortcut was that you add exponents. So that becomes a to the 6th, and we just keep our b squared. When you have a power to a power, I'll just keep our 3a to the 4th, and we are going to cube that. When you have a power to a power, first of all, you take everything in that parentheses to that power. So this 3 is taken to the 3rd power, and this a to the 4th is taken to the 3rd power. 3 to the 3rd is 3 times 3 times 3, which is 27. And a to the 4th to the 3rd is a to the 4th times a to the 4th times a to the 4th. And the shortcut we used, that you multiplied exponents 4 times 3 is 12. And so this become 27a to the 12th. When you divide like bases, the question, the way we phrased it is, yes, you subtract the exponents, but how many are left and where are they located? If I had x to the 10th y squared divided by x to the 3rd y to the 8th, yes, we're subtracting exponents, but don't make the mistake of writing this as x to the 7th y to the 6th as if those are both in the numerator, because they're not. X to the 10th is in the numerator, x to the 3rd in the denominator. So 3 of these are subtracted from those 10, and so we do have x to the 7th in the numerator. But 2 of these y's, because it's y times y, takes out 2 of these, and we're left with y to the 6th in the denominator. All right, the 0 power property was pretty straightforward. Anything at all that you have raised to the 0 power, you could have a big complicated thing in here. 12a squared b to the 10th over c to the 4th. And if this whole thing is being raised to the 0 power, anything to the 0 power is 1. Next thing to review, we called it the KFC acronym. When you have a problem, you go through it methodically. Anything that has a positive exponent, that factor is kept at its location. Any factor that has a negative exponent is flipped. If the negative exponent is in the numerator, it's flipped down to the denominator, thus making the exponent positive. If the negative exponent is down in the numerator, you flip it up to the, down in the denominator, you flip it up to the numerator, and doing so makes the negative exponent positive. And after you've done your keep flip part, then you go through and combine any like bases that you have. All right, I tried to put all the properties in this problem, so we'll see if I succeeded. So first of all, we are squaring this first parentheses. That means each factor in here has to be squared. So 3 squared is 9, x squared is x squared, and y to the negative 3 squared would be y to the negative 6. Down in the numerator, you kind of have a choice. You could do each of these to the negative 3 power, or we could flip this whole thing up, and that would make this negative 3 a positive 3. And with this negative sign in front of that 2, that might make this problem easier. So there is not just one way, but I think that's the method I'm going to choose. So I'm going to take that whole parenthesis, because the whole thing was being raised to the negative 3rd power, and let's flip it up here. So I'm not quite done with my keep flip part, because this y has a negative exponent, so we're going to flip that down. So I'm just going to leave my 9x squared alone, but let's go ahead and take this negative 2 to the 3rd power. So negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. And then x to the 3rd power is just x to the 3rd. And the only thing I have down here in the denominator is that y to the 6th. So when I flip that down, notice that the negative 6 exponent became a positive 6 exponent. So the last step here, I can do some multiplying. Negative 72, and then x squared times x to the 3rd is x to the 5th. And I still have my y to the 6th in the denominator. So hope that's enough of a refresher for problems 9 to 14. Okay, kind of looking over the rest of the packet here, I think 15 and 16 are okay. Remember, when you distribute the negative sign, it changes the sign of everything in the parentheses. Watch your combining like terms. For 17 to 20, we already reviewed foiling. In 21 and 22, that is more than foiling. You have a binomial times a trinomial, so I hope you're seeing that there will be 6 multiplyings that you have to do, and then you will be combining like terms. 23 and 24, remember, those are foiling because you're squaring a binomial. 25, just divide each term in that parentheses by the 6x. For 26 to 29, I already reviewed factoring. You're going to have to remember what a GCF is, greatest common factor. Your life will be easier if you do look for that, and I believe I see a GCF in both 28 and 29. And remember, these are just asking you to factor completely. It doesn't say solve, it's just factor. Okay, 30 and 31, review the quadratic formula. I'd kind of like to not go over an example here. Just find your A, B, and C, plug them in, and if you really can't remember quadratic formula, go on Khan Academy and look it up. You're perfectly capable. So the last thing I want to review, this last part, is function notation. It may just not look familiar to you, and it's very, very important. So we better go over this. So my little example here, if h of x equals x squared plus 3x, remember h is not a variable, it's a name. It's like saying that this function is going to be called Howard, and Howard is telling us that we take our value, we square it, we also take our value and multiply it by 3, and then we add them. So when we read this, we say h of x equals x squared plus 3x, and we need to know how to find something like h of negative 3. Notice where the x was, we put a negative 3, and so that's what we do here. We put the negative 3 in where the x is, following the rules of the function here. So squaring negative 3, I get 9, plus 6 is 15. So h of negative 3 is 15. And then you just do the adding or subtracting or whatever the directions tell you when you find the function notation and do the operation. All right, congratulations. You have completed all the videos for your summer packet. Finish it up, bring it the first day of school. I can't wait to see you, all the fun we're going to have. We'll get started in August.